Hi, I am Syed on Maths Online. Today's topic is normal distribution. Let me define the basic definition for normal distribution. Normal distribution is a continuous probability distribution. So let me write down the definition. The continuous probability distribution having the probability density function or we can even write this as PDF, probability density function. This probability density function for the normal distribution is given by f of x is equals to 1 by sigma square root of 2 pi. It is e power of minus of x minus of mu whole square, and is divided by 2 times of sigma square, where this value of x value is ranging between minus infinity to plus infinity. The value of mean mu is also ranging from minus infinity to plus infinity, and the standard deviation sigma is a positive value, is known as the normal distribution. Is known as the normal distribution. Now this function f of x is a probability density function. It has to satisfy two properties. That is, the value of f of x is greater than or equals to 0. That is the first condition. So this function f of x should be greater than or equals to 0. The second condition is that integral minus infinity to plus infinity, the function f of x dx should be equals to 1. So both the condition will be satisfied by the probability density function. Now let us see what is a normal curve. Suppose if we take the given function f of x and try to plot the graph for this given function, the graph will look somewhat like this. Suppose if I consider this is the coordinate axis, right? So this type of curve is called as a normal curve, which is a bell-shaped curve, and the area enclosed, suppose if this is the origin O, if I am taking, alright, and the area on the right hand side will be equals to the area on the left hand side. So the curve is symmetrical about this axis, alright. Suppose if you want to find out the area enclosed by this normal curve, say between the point this 0 to some say point z, if you want to find out the area enclosed by the given curve between these point 0 to z, then we can use this formula. 5 of z is equals to 1 by square root of 2 pi. It is integral of 0 to z e power of minus of z square by 2 into dz, where this value of z that we have, the value of z is x minus of mu divided by sigma, and this z is called as the standard normal variate. This standard normal variate, or in short we can write SNV, standard normal variate. And the area enclosed on this entire curve is always equals to 1, because we know that integral between minus infinity to plus infinity, f of x dx will be equals to 1. Now instead of the given function f of x, here I am trying to calculate f of phi of z. Therefore we can say that integral of minus infinity to plus infinity f of z dz, its value will be equals to 1. That means the area enclosed under this normal curve, the entire normal curve, its area will be equals to 1. Now suppose if I rewrite this in the form of the probability, so the probability that the value of z lies between minus infinity to plus infinity, its value will be equals to 1. So same expression in terms of the probability. The second result is integral minus infinity to 0 phi of z into dz, its value will be 0.5. Therefore you can write in terms of probability when the value of z lies between minus infinity to 0, it's 0.5. Or the same thing can be written as probability when the value of z is less than or equals to 0, its value will be equals to 0.5. In the same way, if you want to write in terms of integral 0 to infinity phi of z dz, its value will be 0.5. Or 0 to infinity can be written as probability when the value of z lies between 0 to infinity will be 0.5. Same thing can be written as probability when the value of z is greater than or equals to 0 will be equals to 0.5. If you want to write down one more result, if you have integral minus infinity to say z1, right, it is phi of z into dz. Right, in terms of the probabilities over here, in terms of the probability you can write probability when the value of z lies between minus infinity to z1. So same thing can be written as probability when the value of z lies between minus infinity to 0, as we written in this case. Plus, again because it is up to z1, so you have to write probability when the value of z lies between, you left at 0, so from 0 to z1. But probability minus infinity to 0, minus infinity to 0, its value is 0.5. So you can write 0.5 plus probability when the value of z is lying between 0 to z1. Alright, so this probability can be written in terms of 5 of this value, 5 of z1, because 0 to z1 is similar to 0 to z. If it is 0 to z, you write 5 of z. So because it is 0 to z1 over here, we write 5 of z1. And similarly, we can write one more result. The value of z is less than z1. You can write in this way also. Just ignoring that minus infinity. It is understood that when z is less than z1, the value of z lies between minus infinity to z1. Next result we have probability when it is 5 of z into dz, when the value of this z is starting from z2 up to infinity. What will be its value? So probability when the value of z lies between so we have integral z2 to infinity 5 of z dz in terms of the probability lying between z2 to infinity. So which represents that it is nothing but the probability when the value of z is greater than z2. z2 to infinity means the value of z is greater than z2. So this can be written in the form of probability when the value of z is greater than z2 means definitely the value of z is greater than or equals to 0. Right, so that means I am taking from 0 to z2. Actual values that you have over here, suppose if you are taking the value of z over here, so you are having some 0, and here you are having z2, and somewhere over here you have infinity. So the value is from z2 to infinity. That is what we have to take, z2 to infinity. So what I am writing, first I am writing probability z greater than or equals to 0. That means I am taking from 0 to infinity. So what is the additional value I have taken? The additional value that I have taken is from 0 to z2. Actual value is from z2 to infinity, but I have taken from 0 to infinity. What is the additional value I have taken? This is the additional value that I have taken, right, 0 to z2. So that value has to be subtracted here, minus probability when the value of z is lying between 0 to z2. That value has to be subtracted. So we have probability when the value of z is greater than or equals to 0, its value will be equals to 0.5. Right? It is right hand side of the normal curve, 0.5 area, minus this value. Whenever you have probability 0 to certain value of z, you can write 5 of that z value. Z value over here is z2. So these are some of the basic results that you have to remember. So find the area under the standard normal curve between z is equals to 0 and 1.55. So let us draw the standard normal curve. So this is your normal curve, right? So the normal curve will not touch the coordinate axis. It runs parallel on both the sides. Right, so from 0 to 0 to, so this value of z is 0 to 1.55. Suppose if I am taking the point somewhere over here, it's 1.55. So what I have to calculate is, I have to calculate the area under this normal curve. That is the area I need to calculate. So we know the theoretical area. So the formula for area I have given you, it is 1 by square root of 2 pi. It is integral of 0 to z. So the normal formula that I have given to you, if you can remember this formula phi of z, 1 by square root of 2 pi integral 0 to z e power of minus z square by 2 into dz. So I am using that formula over here. So we use the formula over here. It is area 1 by root of 2 pi integral 0 to z. What is the value of z here? 1.55. It is 1.55 into what you have, e power of minus z square by 2 into dz. So this given result, 1 by root of 2 pi integral 0 to 1.55 e power of minus z square by 2 into dz can be written in the form of what? Can be written as phi of z. So if I write down that value to be equals to 5 of z, but in the place of z what you have? In the place of z you have 1.55. So you got phi of 1.55. But what is phi of 1.55 in the given question? 0.4394. So 0.4394. That will be the required solution. Let us take another example. So once again, let us draw the normal curve. So this is the normal curve you have with respect to the coordinate axis. So it is 0 to minus 0.86 somewhere over here. So we need to find out this area. Alright. So we have area to be equals to 1 by square root of 2 pi. It is integral of minus 0.86 to 0. That's the result given. And we have e power of minus z square by 2 into dz, which will be equals to 1 by square root of 2 pi. It is integral of, now because it is minus 0.86 to 0, if you want to make it as positive, but we know that the area on the left hand side, suppose if I take the point over here as 0.86 plus 0.86, we know the area enclosed on the right hand side will be exactly equals to the area enclosed on the left hand side. So instead of taking minus 0.86 to 0, we will take the value to be equals to 0 to 0.86, because the curve is symmetrical about the axis. So the area on the left hand side and the area on the right hand side are the same, therefore we will take 0 to 0.86. And the function, it is e power of minus z square by 2 into dz, will be as it is. So this represents your 5 of z value. Z is what? 0.86. But what is 5 of 0.86 value? It is nothing but 0.3051. That is the required solution. So the next question is, evaluate the following probabilities with the help of the normal probability table. 4 results are given. You can evaluate by using the normal probability table, or normal probability table values are already given over here, so you can just refer this values and then write down the solution. So let us start with the first result. The first result that we have is probability when the value of z is greater than or equals to 0.85. To solve this one, we'll refer back result number 5 that I have given you earlier. The formula, we have probability when the value of z is greater than z2. If you can remember this result I have given you, result number 5. So it is probability that z is greater than or equals to 0 minus probability that the value of z lies between 0 to z2. So this can be written as greater than or equals to 0 will be 0.5 minus this will be 5 of z2 value. So you can write down this one. So or else you can directly remember this formula. Whenever you have greater than some value z2, it will always be 0.5 minus 5 of the z2. So if you want to write directly, you can write this value to be equals to 0.5. Alright, this particular value, it is 0.5 minus 5 of z2. So here 5 of what you have, 5 of 0.85. So it is 0.5 minus 5 of 0.85. You can refer its value will be 0.3023. Alright, evaluate this value and see how much you're getting. We're getting the value to be 0.1977. Then move on to the next result. Next result, probability when minus 1.64 is less than or equals to z is less than or equals to minus 0.88. Right? So to evaluate this result, because both are negative values, you can write in terms of the positive. So positive value, because we know that the area on the left hand side and right hand side of the normal curve is the same. You can use convert this negative into positive as 0.88 less than or equals to z is less than or equals to 1.64. So this can be further written in the form of the probabilities z lying between 0 to 1.64, and because I have already taken from 0 to 1.64, I have to subtract the given value minus probability when the value of z lies between 0 to 0.88. This is the value that I am writing. So what value you have, if you want to check this one, so the values, suppose you are taking a number line over here, you are having 0 over here, it is 0.88 you have, and you have 1.64. so what you are doing is you are taking first value from 0 to 1.64, directly from 0 to 1.64, but you want the values only between 0.88 to 1.64, 0.8 to 1.64, but you have taken additional how much value from 0 to 0.88, so you have to subtract that from 0 to 0.88. This value has to be subtracted. So this value will be 5 of 1.64 minus this will be again 5 of 0.88. But 5 of 1.64, if you go back and refer this one, 5 of 1.64 value is known and 5 of 0.88 value is known. You just plug in those two values. It is 0.4495 minus 0.3106. Right? Its value will be equals to 0.1389. Now let us move on to the third result. So refer back the question. Third result is probability when the value of z is less than or equals to minus 2.43. Because it is a negative value, if you write in terms of the positive value, it becomes z greater than. So when you write greater than, this negative sign will go off and you will be getting the value to be equals to plus 2.43, which will be equals to, again, because it is probability of z greater than z2, similar to this result. Result number 1, z is greater than z2, so probability of z greater than or equals to 0 minus probability 0 to z2. The same thing you can write over here, probability when the value of z is greater than or equals to 0 minus probability when the value of z lies between 0 to z2. z2 value is 2.43. 0.43. So probability of z greater than or equals to 0 will always be 0.5. You have to remember this value. Minus probability 0 to z2 will be always 5 of z2. 5 of z2 value is 2.43. This is 0.5 minus 5 of 2.43 is already given over here in the equation. It is 0.4925. So write down that value, 0.4925. Subtract this one and see how much will be getting. So you get the value to be equals to 0.0075. That's the result. Now move on to the next result. Result number 4. Result number 4, if you refer back to the equation, it is probability when modulus of z is less than or equals to 1.94. Because modulus is there, if you eliminate the modulus, the value of z will be negative as well as positive. So therefore you will be getting minus 1.94 to plus 1.94. But this result can be written as, because we know that whenever you have integral minus a to plus a f of x into dx. So this value can be written as 2 times of integral 0 to a f of x into dx, one of the properties of integration. The similar result can be applied over here. I can write 2 times of probability when the value of z lies between 0 to 1.94, so which is nothing but 2 times of. So whenever you have the value between probability 0 to z2, it will be 5 of z2. z2 value is 1.94, which will be 2 times of 5 of 1.94 is already given over here. 5 of 1.94 in the equation is given as 0.4738. So plug in over here, it is 0.4738. Multiply this one, we will be getting 0.9476. That is the solution you have. So those are some of the basic problems on normal distribution. In the next video, we'll try to see a few more problems in non-normal distribution. Thank you.